Hello again, everyone. So I hope again you're all having a good day. So now let's move on to our next lesson, which is the gradient. So for the gradient, we have two types of gradient, which is arithmetic gradient and a geometric gradient. So from the word itself, if you remember, we have a lesson in algebra, which is the arithmetic progression and geometric progression. So the idea here is slightly the same, but of course the solving or the solution is totally different. But the definition is the same. So what is arithmetic gradient? So arithmetic gradient, this is where the payments decreases or increases each year by a constant amount. So what do you mean by that? So let's say for year one. So for year one, for example, we have to pay let's say 1,000. Okay. Let's say we have to pay 1,000. Then for the year two, we have to pay 2,000. For the year three, we have to pay 3,000, and for the year four, we have to pay 4,000, and so on and so forth. So as you can see, the amount that we pay for each year increases by how much? By 1,000. So that's a constant amount each year. Okay, so just from 1,000 to 2,000, 3,000, 4,000. Or another example is we can also have, so that is increasing. Okay, the payment that you are making increases each year. Or for another example, let's say for year one, let's say you are paying, let's say 5,000. Okay, let's say 5,000, and then for year two or for the next year, you are paying now, let's say for 4,500, and then for year three, you are paying 4,000, and for the year four, you are paying 3,500. So as you can see, now the payment decreases, so it can either increase or decrease. Okay, so that is arithmetic region. And then with that definition, I think we can go for our first example. Okay, now we have our first example, which is a man pays his debt in the following manner. So 1,000 after 1 year, 900 after 2 years, 800 after 3 years, and so on up to 6 years. So find the accumulated amount of these payments at the rate of 10% compounded annually. So now we are asked to find the accumulated amount. So first, we have to know where is the focal date. So as you can see, find the accumulated amount. So most probably, we have the focal date will be the last year, whatever that last year is. So for this example, the last year is the 6th year. Therefore, our focal date will be the year 6. Now let's try to draw the cash flow diagram first. Okay, so we'll have here. So this is year 0 and 1, 2, 3, 0, 1. Okay, so this is year 0, 1, 2, 5, and 6. Okay, so as you can see, a man pays his debt in the following manner: 1,000 after 1 year. Okay, so after 1 year, so it must be on the first month. So we have a payment here of 1,000. Okay, and then 900 after 2 years. Okay, so we have a payment here of 900, and then for the third year, this will become 800, and of course this will become 700, and then 600, and then 500. Okay, so as you can see, the payment decreases by how much? By 100 pesos. So that's from 1,000 to 900 to 800 to 700, and so on. So that is up to 6 year. Therefore, we have to remember that these values, we have to bring all of these values on the 6th year. Okay, and then remember that we have a 10% compounded annually. So that is annually. So that means it doesn't matter if that is I or J. So we can just make this I since the n is equal to 1. So we can make that this I is equal to 10%. J or I doesn't matter because n is equal to 1. Okay? Because it's annually. Now, don't be confused. This is not an annuity. Okay? Because again, the definition of annuity is the payment must be equal all throughout the year, all throughout the payment. But as you can see, this is the payments here are not equal. So this is not an annuity. So how will we bring all these values, for example, that 1,000 to the year 6? Okay. So let's remember that our um, focal date is year 6. Let's change the color of that so that we can remember. So focal date is year 6. So we have to bring 1,000 to the 6 here, 900 to year 6, 800 to year 6, etc. Again, this is not an annuity. Therefore, we will have to bring these values one by one individually. So we have to bring 1,000 to year 6, 900 to year 6 individually one by one. Okay, so bringing all of that, um, let's say that this is year 1. Okay, um, let's just call the 1,000 or the year 1 F1. Okay, so again, we have to bring all of those money into year 6. So let's say F1. Okay, so bringing 1,000 to year 6, 1,000 to year 6. So we have to apply now the compound interest because that is a single payment. That's not multiple payments. Therefore, that is not an annuity. Now we have to um, apply now the compound interest formula, which is the 1 plus I raised to yn. But n again is equal to 1. So you can just neglect that because that is just equal to 1. So all we have to do is just take note of the y. Okay, so that's 1,000. You have to bring it to 6. So that's from year 1 to year 6. That is 5 years, right? So that is 1 plus the I is 10%. So that is 0.1 raised to 5. Okay, so you're going to write or you're going to the future, it must be positive. The exponent must be positive. Next, okay, bringing F2. F2 is this one, 900. This is F1, this is F2. F2 is stands for the year. Okay, so this is 900 now times 1 plus 0.1 raised to, that's 2 to 6, so that is raised to 4. Okay, and then F3 now, this is 800. I hope this is okay that I just make this 1.1. That's 1 plus zero point 0.1. That is 1.1. Okay. So this is raised to 3. And then F4. F4 is this one. So this is equal to 700 1.1 raised to 2. Right? And then F5 is equal to 600 raised to 1.1 raised to 1. Okay, I won't writing that anymore. And then F6, since F6 is already at the 6th year, this is just 500. Now let's compute these one by one. Okay. So computing that one by one. Okay, I suggest that you do this also with me so that you can follow what I am doing. So that's 1.1 raised to 5. That's 1610.51 raised to 4. 317.69 mhm, raised to 3. This is 1064.8. This is 847. This is 600. 60, and this is 500. So as you can see, all of these values are already in the year 6. So all you have to do is just add all of this one. So adding all of those is 1610.51. Mhm. Point 8 plus, that's 847, 60 plus 500. That is exactly 6,000. So that is exactly 6,000. Okay. So this will be your final answer. Now, as you can see, the solution is quite long. So you can do this if the years are just maybe 6 years or 4 years or 5 years. So what if the question comes with up to 20 years, after 30 years? So that will be, the solution will just be too long and will be prone to error. Okay, so aside from that, you have to round off every answer, so the error of rounding off keeps getting bigger and bigger as you round off, as you go to the years. Okay, so what can you do? We can actually solve this with just one line using the symbol, the summation function is really useful for this one. Now, however, before you can use the summation function, you have to derive your own formula, which is the hard part. Okay, but don't worry, I'll try my best to explain this to you. Now, as you can see, we have an answer of 6,000, so we can just simply rememorize that. I will remove all the answers. There you go. Now, let's try to derive a formula use so that we can use a summation function. So this is equal, as you can see, this is 1000 times 1.1 raised to 5. Okay, and then this one, instead of making it 900, we have to derive a formula for f1 to f6. Now deriving that, we will not put 900. Instead, we will put here 1000, that is minus 100, right? That's one, 1 minus 1000 times 1000 minus 100, that will become 100. Okay, so this is times 1.1 raised to 4. Next, so this will become 1000, okay, minus 200, right? 1.1 raised to 4. Or we can also rewrite this part to make it look similar to this. This is 1000 minus 1000, rewriting this equation, minus 100 times 2, right? That is just the same, raised to 4. Okay. Now, how about for this one? So this one, we can rewrite this as 1000 minus 100. To make it 700, we have to subtract here 300, right? So this is times 3 raised to 1.1 raised to 3. Oh, oh, sorry. So this must be 3. Sorry about that. So this must be 3, this must be 3, and this must be 2. Okay. And then for this one, this will become now 1000 minus 100 times now to 4. Okay. 1.1 raised to squared. So following this one, no, this is not 2, this must be 1. Okay. For the last one, so this will become 1000 minus 100 times 5, 1.1 raised to what? So this is As you can see, the 5, 4, 3, 2, 1. So this must be raised to 0, which is just equal to 1. So that will become 500 also. So now, looking at those, you get a pattern or a formula. Now, deriving the formula, the general formula will be, if we can say, as you can see, we have F1, F2, F3 up to F6. If I will say that this is I will say that this is Fn. Whatever the value of n, you'll have here 1000. That's a constant, right? They all have 1000. As you can see, from here, this is originally, we have here 1, right? We have here 1. 1, and then this is 2, this is 3, this is 4, and this is 5. As you can see, if this is 1, this is 2. Okay? And if this is 2, okay, if this is 2, this is 3. If this is 3, this is 4. If this is 4, this is 5. And finally, if this is 5, this will be 6. So as you can see, the pattern is just minus 1. Therefore, I can say the general formula will be minus 100 is a constant. So 100 times what? If this is n, okay, so this one must be minus 1. So subtracted to 1 to have this one. So this must be n minus 1. Okay, n minus 1 times 1.1 raised to what? As you can see, if this is 1, if this is 1, this is 5. If this is 2, this is 4. If this is 3, this is also 3. If this is 4, this is 2. As you can see, the sum of these two, that's 1 and 5, that is 6. 2 plus 4, that is 6. 3 plus 3, that is 6. 4 plus 2, that is 6. So it has something to do with 6. Okay? Okay. So you have to think of this one. Okay? So thinking about this one, the formula or the exponent of the 1.1 will just be, nope, this is just 6. Okay? 6 minus n. So this will be the general formula. Now, let's try it out if this will work right. So let's say that we have to get F5. Okay, so for this one, let's say we have to get F5. So F5, if n is equal to 5, therefore this one will be 5 minus 1, that will be 4, which is also 4 here. And then that is 6 minus n. Again, n is equal to 5. So 6 minus 5 is 1, which is also 1 here. Okay. So we have the right formula now. Now, how we will use the summation part? So using the summation part, all you have to do for this one is just input this in your calcu. So that is the summation, okay, the summation sign, and input this formula, that is 1000 minus. I think it's better when you use this in your calcu, there will be an initial parenthesis. So this is the initial parenthesis that's already written. So let's make another one. So that's 1000 um 100. This is how you exactly enter it in your calcu. And then see, we will not use n, okay? So since we are dealing with your calcu, the only variable there, or what we usually use, is x. So that's, let's say that is x. So replacing n with x minus 1. Okay, so you have here two parentheses, so we have to make another parenthesis, and then times 1.1 raised to 6 minus x, and then close it again. So then you will see here x equal, and then another box here on the top of the summation symbol. So this indicates on what value you want to start. So you can see we started at 1, right? at 1. So we have to put it here 1, and then the top value, or the value on the top of the summation symbol, is the final value that you want. So at that value it will stop. So that is 6. So this is 6. Now if you will enter this in your calcu, we will also get the value of 6,000. Now, as you can see, um, we can also use this one, the summation part or the summation method, or the manual part. But as you can see, there's no way for you to do the manual part if the problem asks for maybe 20 years or 30 years. It will take you too long to solve the problem. Okay, so the summation method is really really useful, or the summation symbol, if you use the summation function is really useful. So what the summation function does is simply, from 1, he will, it will substitute the value of 1 here first, and then he will get a value, and then after 1 he will substitute 2, and then another value, and then 3, another value, up to 6. So whatever value is the last part, whatever the value of the top part, and then after that he will now, the calcul now will add all of those. Okay, so this is just the same, the method is just the same, and it is way shorter than the long method. Okay, so with that, I think we can move on to our next problem. Okay, so going for our next problem, which is the maintenance cost for a sewing machine after 1 year is expected to be 500 pesos. So the cost will increase by 50 each year for the subsequent 9 years. So the interest is 11% and compounded annually. So what is the present worth of maintenance for the machine over the full 10 years? Okay, so as you can see, now the price, or the payment, or the maintenance of the sewing machine is initially 500, then it increases 50 pesos each year. Okay, so 500 now, next year will be 550, next year will be 600, next year will be 650, and so on. So the the part that is confusing here, so what does the subsequent mean? Subsequent means the following years. Okay, so as you can see, we have here 500 after 1 year. Okay, so that means that we have 500 for that year, and then you have to count again another 9 years. That's why at the end of the problem, it's a full 10 years. Okay, so that's 1 year plus another 9 years, so that's 10 years. Okay. Okay, so drawing the cash flow diagram again. Okay, cash flow diagram. So that's 0, 1, 2. Okay, so let's say this is our 0, 1, 6, 9, 10. Okay, so that's a total of 10 years. Okay, and then so this one we have a payment here. So as you can see, what's written here is after 1 year. So at year 1, you have a payment of 500. Okay, 500. At year 2, you will have a payment here of 550. And year 3, we have a payment here of 600. We have a payment here of 650, and so on. Okay, I will no longer put all of the values. Now, we are asked to find what is the present worth. So that means the present worth. So we have to bring all of these values into year 0. So present worth to year 0. Okay, now let's remember that the focal date must be year 0. Okay. Okay, so let's try to bring the 500 first to year 0. Let's say that is P1. Okay, that's P1. That must be equal to 500. So we have to apply again the formula for compound interest. So that is 1 plus, what is the interest? We have an interest rate of 11% compounded annually. So again, it doesn't matter if that is I or J, okay? Because that is compounded annually. Therefore, N is equal to 1. So 1 plus 11%, that's 0.11 raised to how many years? That is equal to 1 year. You have to bring it back 1 year. Again, that must be negative because we are going to the present or going to the left. Now, for P2 now, P2 is equal to 550, right? That's 1 plus 0.11, that's just 1.11, right? Raised to negative 2. And then P3 is equal to P3 600, that's 600 raised to 1.11 raised to negative 3. And then P4 is equal to 650, 1.11 raised to negative 4. Now, from this point, I hope you can see already a pattern or a formula for this one. So you will be doing this up to P10, right? Because up to P10 there will be an amount here, and then you have to bring it back 10 years. Now, we can now use the summation, or we can now derive the formula to in order for us to use the summation function. Now, rewriting this one, okay? So rewriting this one, you can have here, no, not that one. So rewriting this one, you can have here 500 plus 50, okay, plus 50 times 1.11 raised to negative 2. And rewriting this one, you'll have here 500 plus 50, that will be times 2, right? Times 2 times 1.11 raised to negative 3. And then this is equal to 500 plus 50 times 3, right? Times 3, 1.1 raised to negative 4. So from that, as you can see, there's another pattern or formula. So deriving the formula, you can have here, let's say if this is Pn, or let's just say directly Px, this is equal to what? As you can see, we have here 500. 500 is a constant in all of the formulas. Plus 50 is also constant. Okay, 50 is also constant. So this is, if this is 1, right? We have here 1. So if this is 1, this is 2. If this is 2, this is 3. If this is 3, this is 4. Therefore, I can simply say that this is x. We have to subtract this by 1. So this x must be subtracted by 1. There you go. And then another 1.11 raised to what? If this is 1, this is also 1. If this is 2, this is also 2. If this is 3, this is also 3. So this is just simply negative x. And then all you have to do is just add the summation function. Summation function. Okay, and then you'll have here a large parenthesis or bracket. And then this is x equal to, what is the first value? First value is equal to 1. And then the last value is, no, not 4. The last value is 10, right? Because that is 10 years. So this must be x equal to 1, and then the top part, or the top part of the summation symbol, must be equal to 10. Okay, so let's try to put that in the calcu. 500 plus 50 times. I suggest that you try this also in your calcu so that you'll know how to use the summation sign. So this is from 1 to 10. Therefore, our answer, or px, or let's say that this is p0, right? Or let's just call it p only. This is 4020.7011. So I think the hardest part here is you have to derive your own formula. I think that's the hardest part. But other than that, if you can derive your formula smoothly, and I'm sure that you can get this problem easy and faster than the long method. Instead of making adding or solving for P1 up to P10 and then adding all of that, that is very prone to error when inputting it in your calcu. So I think this way is much better since it is shorter. As you can see, that's only one line, and then you'll get the final answer right away. So with that, that's all for this video. I hope this is enough for you and I was able to help you with this lesson for the arithmetic region. So I suggest that you also watch my next video, which is the another type of region, which is geometric region. So with that, I hope you are all guys having a good day, and of course don't forget to subscribe to my YouTube channel, and then of course also hit that notification bell button so that you'll be notified as soon as I upload a new one. So I hope you guys are staying at your home, practice social distancing, and keep safe everyone, and I'll see you on the next one. Bye bye, and thank you for watching. Bye bye.